You know that moment when you pull out your phone to snap a quick picture, but the camera just won't focus? It hunts back and forth, the image goes blurry, and you have to wait for it to finally lock onto your subject. Now, think about your own eyes. You shift your gaze from your phone to the wall, to the window, and back again. Your eyes perform that exact same physical focusing process instantly, flawlessly, thousands of times a day. In a very real sense, the human eye is the original, most advanced camera on Earth. It's a roughly spherical system, built from two separate parts fused together and packed with precise biological machinery. Just like a high-end camera needs a durable outer body, your eye is wrapped in a tough, white protective shell. It's that visible white part of the eye, and it keeps all the delicate inner workings safe. And to keep that shell in top shape, there is an invisible maintenance layer. This thin, clear film secretes tears to keep the whole system lubricated and clear of dust. These rugged, self-cleaning outer layers form a strong physical foundation. They do the heavy lifting of protection, so the precise parts inside can operate safely. When light first enters this biological camera, it hits a clear front window. This curved surface does the first bit of work, bending light rays and aiming them inward. This diagram shows the colored ring and central black opening acting as an aperture. In bright light, the ring automatically shrinks the opening, keeping the delicate interior from getting too much light. In darkness, the ring pulls back, widening the opening so you can see. Once the light passes through that opening, it reaches a flexible focusing disc. This transparent, oval-shaped part sits right in the middle of the eye. Try this out. Hold your finger up in front of your face. Focus entirely on it, and notice how the room behind becomes blurry. Now do the opposite. Keep your finger right where it is, but focus your eyes on the distant background. Instantly, your finger becomes a blur. What you just did is use your eye's biological autofocus. It's a physical change you command to shift your vision from close-up to far away. This diagram shows your focusing muscles squeezing inward to help you see things up close, making the flexible disc bulge and thicken. When looking far away, those muscles relax, pulling the disc thin and flat to see the distant background clearly. Unlike the rigid glass lenses in a phone, your eyes dynamically warp their own biology in real time to find the perfect focus. Now, that perfectly focused light travels through the center of the eye, which is filled with a clear, protective jelly. This jelly keeps the eye plump and perfectly round. Light lands on the back wall of the eye, which acts like a high-resolution digital sensor to capture the image. Millions of specialized cells instantly convert that picture into electrical pulses, traveling rapidly down the optic nerve. These signals travel down a main data cable directly to your brain, where the image is actually processed and perceived. It's an incredibly synchronized loop. The outer shell protects, the colored ring controls the lighting, the focus muscles warp the lens, and the back wall captures it. This all happens in a fraction of a second, flawlessly processing up to 12 million different colors entirely in the background of your mind. So the next time you look up to admire a sunset, you'll know exactly what's happening. Your biological autofocus just shifted gears to give you a perfectly crisp view of the world.